Assalamu alaikum, welcome back to my channel. I hope you all are well. So this video is going to be the second part of the topic that we started in the previous video, that was the periodic classification of elements. In the previous video, we learned that what was the need of classifying the elements in the form of periodic table. In this particular video, I'll be telling you the history behind the classification and we'll be starting with the Dobereiners Triad. So most probably, in the beginning, attempts were made by chemists to classify elements on the basis of factors such as density, malleability, ductility, etc. And also to consider whether they are metals or non-metals. Because various elements were discovered between 18th to the 19th century, as I told you in the previous video. Now it was found that some were metals, some were non-metals, and we classify non-metals and metals on the basis of malleability, ductility, density, etc., etc., etc. So these were taken as the basis for their classification, but none of these early classifications proved satisfactory enough. You know the reason why? Yes, this is because the number of elements falling in a particular group was so large a number that it did not serve the purpose of generalization. Getting my point? Yep. Now, some of the characteristics being considered varied under differing conditions. Like, for example, there were certain kinds of metals placed and non-metals. There were two groups made, for example. Okay, for instance, group metals and non-metals. Now, in the group of metals, first of all, it was not a generalized study. We were taking all the elements on a whole. Now the metals will also differ in themselves. Some metals might have similar properties, some might not have similar properties, right? So there was not a generalized study of elements. It was not so convenient in studying, right? Then we have certain elements showed metallic as well as non-metallic characteristics. Right, now that we know metalloids, earlier it was not known. Earlier it was becoming difficult to analyze the properties because there were certain elements which existed which has the properties of both metals and non-metals. Right? Okay. Now, obviously, scientists were in search of characteristics of an element that would never change. Of course, they needed such kind of basis of classification that would never change, so that they can make the comparative study easier and more convenient, right? And the purpose for classifying elements and the proper classification might occur properly. Now came another scientist, that was William Prout. Yeah, you're right, that was William Prout. He was the one who discovered that the atomic mass of an element never differs and that it could therefore form a truly scientific basis for satisfactory scheme of classification. So William Prout was the person who found that atomic mass is something that do not differ from one element to the other. Hence, he said that atomic mass can become something, as the basis of the classification of elements. We can classify or generalize elements on the basis of atomic mass. Because the point was that atomic mass, the isotopes were not known at that time. What are isotopes? Yes, isotopes are the elements which are having different mass number but same atomic number. Right. So now at that time, isotopes were not known. Right. So that is why they tried to, or they decided to classify the elements on the basis of atomic mass, which they were thinking that it is something that would not differ from element to another element. Right. Now let's begin with the first scientist, that is the Dobereiner. What did he do in his Dobereiners Triad? Okay, so let's begin with the Dobereiners Triad. In the year 1817, Johannes Dobereiner, he suggested that there are sets of three elements called the triads, which show similar properties with each other. And it was observed that atomic mass of the central element is nearly equal to the arithmetic mean of the limiting elements of the triad. Okay, for instance, let's take if there were three elements in a triad, that was A, B, C, and the atomic masses were X, Y, and Z. So he suggested, or he considered that the atomic mass of B will be the arithmetic mean of the limiting elements, that is A and C. So atomic mass of A plus atomic mass of C upon 2, that is we are taking out the mean here, will be nearly equal to the atomic mass of B. Atomic mass of B, exactly. For example, In his triad, one of the triad that he established was lithium, sodium, and potassium. It was a triad which consisted of lithium, sodium, and potassium. Okay, so what is the atomic mass of lithium? That is, atomic mass of lithium is 7. Atomic mass of sodium is 23, and atomic mass of potassium is 39. Right. Now, if we take out the arithmetic mean of the limiting elements, what we get is that 7 plus 39 upon 2, that is 46 upon 2, that is 23, which is exactly equal to the atomic mass of the middle element, that is sodium. This was his establishment, and this was a relationship that his study established. Like the three elements of a particular triad had similar chemical properties. In fact, Dobereiner, this person called Dobereiner, he was the first scientist to show the clear relationship between the properties of an element and its atomic mass. He was the person who brought the assumption made by William Prout, that was the classification can occur on the basis of atomic mass, into practicality. He was the first scientist to prove the point of William Prout. Okay, now atomic mass of the middle element of a Dobereiner triad was approximately equal to the arithmetic mean or the average of the atomic mass of the other two elements of the triad. Right. So this is what he said. Okay, now let's take three examples. That is calcium, strontium, and barium. This was one of the triad that was established by Dobereiner. So now let's see first of all if this is fulfilling the conditions laid down by him. That is, the atomic mass of the middle element, that is strontium, is equal to the atomic mass of the limiting elements, that is barium and calcium. So the atomic mass of calcium is 40, strontium is 88, and of barium is 137. Now, if we take out the mean of this particular triad, means the limiting elements of the triad, that is 40 plus 137 upon 2, that is 177 upon 2, which is nearly equal to 88.5. That is 88 point. That is 88.5. That is nearly equal to the atomic mass of the middle element, that is strontium, that is 88. Now this triad was found to have similar properties. Like all these three, calcium, strontium, and barium, all these three were metals. Each has an oxide that is alkaline in nature. The nature of their oxide was also similar. That was, they were alkaline in nature, and they had their valency of 2. Now, since these elements having similar chemical properties, they were put together in one group or one family to form a triad that was known as the Dobereiners Triad. Okay, now let me ask you a question. If I ask you the current form of classification of the elements that we have in the form of periodic table, is that, in the form of a triad or what? No, exactly no, right? So this means that the establishment that was laid by Johannes Dobereiner in 1817, that failed, that was discarded. The reason for the discarding of the law of triad was that Dobereiner failed to arrange all the then known elements in the form of triad. He was unable to, arrange all the elements that were known at that time in the form of triads, and he could not establish the properties and the relationship that he laid down. It was applicable in a very few elements like chlorine, bromine, iodine, calcium, strontium, barium, and lithium, sodium, and potassium. So there were certain elements in which his application, his establishment was applicable enough, but not on all the elements. The law did not fully apply even within the same family sometimes. For example, like halogens, group 17 halogens. Okay, group 17 halogens. The first three members, fluorine having the atomic number 19, chlorine 35.5, and bromine 80. It was observed that the mean of the atomic mass of fluorine and bromine is 49.5. It was not 35.5. So it could not, it was not even applicable in the elements of the same family. Hence, his classification was discarded. So Dobereiner's scheme of classification of elements was not very successful, though it did contain important insights and principles. He was the first scientist to establish relationship between the atomic mass of the elements and the periodic properties. But his classification was not applicable enough, was not convenient enough. If we could, if broad on a broader scope, he could not classify all the elements, even occurring in the same family. Hence, his form of classification was discarded and was replaced by another scientist, that was Newland's law of octaves, that we'll be seeing in the next video, inshallah.